Today our lecture is pattern recognitions. So far we have studied coupling constant and multiplicity. In pattern recognition, what we will do, uh, we will identify the different uh, parts, fragments, or functional groups in organic compound. Let's have structures. Uh, Focus on ethyl group. There are three fragments in hydrocarbon: ethyl group, isopropyl, or tertiary butyl. So just focused on these groups, what signals or peaks are obtained for these ethyl, isopropyl, and tertiary butyl. In ethyl, there are two signals having integration value 2 proton and 3 protons. If we draw the structure of ethyl having CH3 and CH2, and we know that in proton NMR, when we talk about uh, 3 proton, when we talk about CH3 3 proton, it means these 3 proton will split 2 proton nearby neighboring proton. So neighboring proton splitting pattern is observed with respect to CH3, means these 3 proton have how much splitting, because these 3 proton have neighbor 2 proton. When there are 2 proton in neighbor, then according to n plus 1 rule we will add 2 proton plus 1, answer will be 3. It means this 3 proton having the splitting of triplet, having the splitting pattern of triplet. So in this spectrum of NMR, a triplet is present here. 3 proton having triplet. It indicates in ethyl group 3 proton having neighbors CH2, having neighbors CH2, or we can say that 2 proton integration of 2 proton is present in a neighboring of CH3. And next group, when we talk about CH2 having neighbor CH3. CH2 having neighbor CH3 means 2 proton having neighbors 3 proton. So when we talk about the multiplicity of these two protons having the multiplicity 2 proton having multiplicity of quartet. Why quartet? 2 protons having multiplicity of quartet. This pattern is observed. Why 2 proton having multiplicity of quartet? Because 2 proton having the neighbors 3 protons CH3s are present in vicinity of CH2. When neighbors having 3 proton, then n plus 1 rule says n plus 1 rule. We put the value of 3 plus 1, answer will be 4. 4 mean quartet. So 2 proton integration value must be quartet. So two clear cut signals having peaks triplet and quartet. Whenever in NMR spectrum triplet and quartet peaks are observed, it is a clear cut clue about ethyl group. It will be clear cut clue of ethyl group. Ethyl group always shows two peaks having triplet and quartet. Now look at another structure having isopropyl group. In isopropyl group, uh, first of all we see the formula of isopropyl group: CH, CH3 and CH3. This is the formula of isopropyl group. In isopropyl group, two peaks are observed. One peak having integration of 1 proton and other peak having integration of 6 proton. First we look the integration 1 proton. When we talk about the integration of 1 protons, CH, it means this single proton having six neighbors proton. This single proton having six neighbor proton. There are two methyl group attached with this carbon. So this proton having six neighboring proton, it means when we talk about the splitting of the single protons, in fact this single proton will split neighbor six proton. So n plus 1 rule, n plus 1 rules, in n plus 1 rule if put the value 6 plus 1, answer will be 7. So septet or multiplet, we can write multiplet or septet peaks will be observed for one proton integration. 7 peaks will be observed. So this 7 peak will be 7 peak will be observed here. Integration one proton having 7 peaks, or sometimes we can say multiplet. Now 6 proton peak having 6 proton peak means with two methyl group CH3 CH3. These 6 proton now split the single proton, because these 6 proton having one neighboring proton. So according to n plus 1 rule, 1 plus 1 answer will be 2, means these 6 proton will split neighboring one proton and doublet will be observed. So doublet will be observed here. Here is a doublet of 6 proton. So integration value 1 and 6 and peaks splitting pattern, both these two information help us to draw accurate structure of organic compound. This NMR is very useful to elucidate the structure of organic compound. And the third group is the tertiary butyl. So in tertiary butyl only single peak is observed. In tertiary butyl only single peak is observed having 9 proton integration value. In tertiary butyl single peak having 9 proton integration value is observed. So look at the structure of tertiary butyl. CH3 CH3 CH3. This is the tertiary butyl. So in tertiary butyl there are 3, 6 and 9 proton. There are 9 proton, and these 9 proton attached to the carbon which have no hydrogen. So hydrogen is missing to this neighboring or surrounding of these 9 proton. When hydrogen is missing or hydrogen is absent in surrounding of these 9 proton, so when we write n plus 1 rule, n plus 1 rule, then 0 plus 1, 0 plus 1, answer will be 1, because 9 proton will split the neighbor, but neighbor is absent. Neighbor is absent means zero, we write 0. 0 plus 1, answer will be 1. So these 9 proton, integration value of 9 proton having peak singlet, So these three fragment or components in hydrocarbon, ethyl, isopropyl and tertiary butyl are very important. When such patterns are observed, then we definitely uh, have a clue about the ethyl, isopropyl and tertiary butyl group. These are the some spectras given. Some spectras are given, and splitting pattern having integration values are also given, and we have to identify whether these spectrum contain ethyl, isopropyl or tertiary butyl groups. So first we read this statement. in 15.17. Below are the NMR spectra of the several compounds. Identify whether these compounds are likely to contain ethyl, isopropyl, and tertiary butyl group. Just we have to identify the ethyl, isopropyl, or tertiary butyl group. In this first spectrum, integration value having 6 proton indicates there must be a isopropyl group. 6. There is a 6 proton integration value and 1 proton. Whenever there is a 6 proton and 1 proton, integration value is present, definitely 100% sure there is a isopropyl group, because in isopropyl CH CH3 CH and CH3. So 6 proton having integration value, 6 proton integration value. Yes, these 6 proton show uh, split this single hydrogen, and doublet will be observed for 6 proton. Doublet doublet is observed here for 6 proton integration value, and this single proton having multiplet or septet, this single proton having showing the septet value. So definitely there is a isopropyl group in this spectrum. And what's about this peaks having 5 proton integration means there is a formula given in organic compound having C9H12, C9 and H12. When C9H12 is a formula given for organic compound, definitely there are 9 carbon. So when there is 9 carbon and 12 hydrogen, first of all calculate index of hydrogen deficiency. Hydrogen index deficiency. Hydrogen index deficiency will give us the clue about the is there any ring, is there any unsaturation. So that give the idea about the degree of unsaturation or ring present, because we will compare it this saturated hydrocarbon. If there are C9, if there are C9 and saturated hydrocarbon, so hydrogen must be 20. Hydrogen must be 20 if there is a saturated hydrocarbon C9 and H20. So compare it H20. Now compare it with H12. There is a difference between 20 and 12 will be 8. So divide it with 2. Divide it with 2. Answer will be 4. It is the index of hydrogen deficiency. So index of hydrogen deficiency is 4. Index of hydrogen deficiency 4 indicates there must be 4 pi bond, or there must be one ring 3 pi bond, and another condition is maybe 4 rings, maybe 2 ring and 2 pi bond, maybe 3 ring and 1 pi bond. There are several possibilities for these 4 degree of unsaturation. So one ring equivalent to 1 pi bond, one ring is equivalent to 1 pi bond. Because there is a 5 proton having peak in downfield above 7. So whenever there are peaks in above 7 ppm or in a downfield position, surely there is aromatic compound. Aromatic compound having hydrogens show the peaks above 7, 8, 9. So definitely there is a aromatic compound. There is aromatic compound. Just we draw simple aromatic compound benzene. So when we draw benzene having 3 pi bond and one ring means 4. 4 degree of unsaturation is satisfied here in this benzene. Now we will draw the isopropyl group CH3. 6 carbon is present in the ring, 7 carbon, 8 carbon and 9, C9. and there are hydrogen 12. There are hydrogen 12. So 6 hydrogen 7, and there are 5 hydrogen here. 1, 2, 3, 4. So that may be aromatic structure having the isopropyl group, and the 5 hydrogen showing this multiplet in aromatic ring. These 5 hydrogen showing the aromatic ring. 5 and 7 will be 12. 7 hydrogen are these and 5 hydrogen aromatic system, and answer will be 12. So there are 9 carbon and 12 hydrogen. There are 9 carbon and 12 hydrogen. Formula is satisfied, and peaks pattern is also satisfied. Same is the case another spectrum having C6H12O2 and C10H14O2, and the fourth spectrum C8H10O. Just we have to identify the pattern of ethyl isopropyl and tertiary butyl. In the first spectrum, I just detailed mentioned how to draw a structure, but in a question statement, there is no need to draw a structure. In a statement, just identify the identify the pattern of ethyl and identify the pattern ethyl isopropyl and tertiary butyl. So we will just focus the question statement. Here, look at the fragmentation pattern. Look the splitting peaks. There are six integration value. Three integration value proton, two and one. So six and one and three, two. Definitely there is isopropyl group and there is ethyl group. Isopropyl and ethyl group are present. Whenever there is, keep in your mind, whenever there is CH3, CH3. So in this isopropyl group, six proton are present and one proton is also present. So where is the peak of one proton? Peak of one proton present here, and where is the peak of six proton present here? Means two peaks are justified, 6 and 1. Remaining two having integration value proton 2 and 3. 2 having quadret and 3 having triplet, or 2 proton integration value having quadret and 3 proton integration value having triplet will be in this case CH3 and CH2 ethyl group. In ethyl group, 3 proton integration value will be triplet and 2 proton integration value will be for quadret. Means just this is a quadret and this is a triplet. So simply four peaks are justified. So these four peaks now are justified. Just we must have these group, isopropyl group and ethyl group. When you have isopropyl and ethyl group, means you have justified these four peaks. Now these fragment connect. Now these fragment connect with each other. Isopropyl group and ethyl group connect with each other. How these are connected? This is very important. How these fragments are connected? This is very important. You have drawn different fragments separately. You have drawn different fragments separately. Isopropyl group drawn separately, ethyl group drawn separately, and then compare these separate fragment with the splitting peaks pattern. Yes, these fragments and splitting peaks pattern are in accordance with the spectrum. Yes, they have justified. When they have justified, now at the end, look at the chemical shift value. Look at the chemical shift value. So chemical shift value having a multiplet, one proton multiplet are separated 5. So 5 means these isopropyl group hydrogen must be attached with oxygen. Hydrogen must be attached with oxygen. Although there is no need to draw a complete structure, just we have to ask, justify the fragments. But for sake of your convenience, how to draw a complete structure, just I'm giving a clue. Oxygen. This is oxygen. CH having CH3 and CH3. Now this single proton attached directly to the oxygen means single proton, one proton integration value having multiplet are separated uh, almost at 5 because oxygen is highly electronegative. And another side, this oxygen having C double bond O, and this carbonyl having CH2 and CH3. Now look the two proton integration value having 2.2, two proton integration. Whenever two proton CH2 group is attached with carbonyl, chemical shift value definitely will be almost 2.23. And similarly, three proton integration value they are about the 1, this show this diagram. And 6 proton integration value 1.3 showing this. So this is our formula: CH3 CH2 C double bond O O CH3. This is ester. How many carbon? There are 6 carbon. Yes. How many hydrogen? There are 12 hydrogen. How many oxygen? 2. So formula is given C6H12O2 is justified. Different fragments connected with each other and our formula is justified. Okay.
Yeah.
Sorry, there will be sound problem disconnected.
No, it's fine.
Okay.